Okay, welcome to Roasted Academy. Today let's talk about exam preparations for physiology, right? What you expected at least to know before you go for your exams for physiology. So, cell physiology should understand what a cell is, right? And the functions of the cell membrane. Should understand also how substances are transported across the cell membrane. There's active transport, there's passive transport, where substances are transported, we have to use energy, okay? And then also where substances are transported across the cell membrane where there's no use of energy. That's passive transport, right? You should be able to differentiate all these and also give out the channels that are involved in that particular case. Those voltage gated channels, ligand, mechanically gated channels, all those things, at least you should be able to know, right? Cell junctions. I've given examples like tight junctions, gap junctions, and desmosomes as well. You should be able to understand the establishment of rest membrane potential. So what is rest membrane potential? Resting membrane potential is simply the voltage that we observe across the cell when the cell is at rest. Any disturbance in this particular rest membrane potential, then action potential is going to be established, right? So after understanding the what rest membrane potential is, then now you have to go to action potentials. In a neuron, you should be able to draw the action potentials in a neuron, in a skeletal muscle, as well as in cardiac muscle. Then also we come to application of action potentials, hyperkalemia and hypokalemia. What are you going to see? What are you going to observe in terms of this of these people? Also, we should talk about neuromuscular junction, right? The connection between a neuron and a muscle, and the application that things that can go wrong at the neuromuscular junction. We have got myasthenia gravis, we have got Lambert-Eaton syndrome, as well as botulism. This is under the action potentials that I've mentioned here. After you've understood about the cell junctions, the transport across substances, establishment of rest membrane potential, action potential, application, the neuromuscular junction. When you come to muscle physiology, here we're trying to understand how muscles are able to contract, right? How it can lead to the contraction of a muscle. Okay, so here we talk about the mechanism of muscle contraction in skeletal muscle. We talk about sliding filament theory. At least you have to know that, right? And also muscle contraction in a smooth muscle. For blood physiology, we take it from the perspective where we start from the components of blood, what is blood itself, what is the function of blood, the red blood cell disorders, the anemias. Know the different types of anemias, should be able to come up with the diagnosis. How do you come up with the diagnosis of anemias? You use these indices. You must know these indices, right? MCV, MCHC, MCH, PCV, etc., right? Also, different types of white blood cells and their functions and components also of plasma, right? On CVS, we concentrate much on ECG. You should be able to know about ECG interpretation and also how to calculate the heart rate. Okay. Also, you have to be able to tell on the ECG that this is tachycardia or this is bradycardia. Okay. We talk about the range of the heartbeats that we should have a range of 60 to 100 beats per minute. Okay. If it's above 100, what is it called? Below 100, bradycardia. Above, tachycardia. Okay. Then also examples of conditions that are experienced in that, right? And then also should be able to explain what blood pressure is, the calculations, different calculations of blood pressure. Cardiac output, stroke volume, preload, all these you are supposed to know about the definition, right? Systolic blood pressure, diastolic blood pressure, total peripheral resistance, and also how we can calculate different parameters, okay? Know about the definition as well as how you can calculate them, right? Like mean arterial pressure, for instance, MAP, how you can calculate cardiac output. For renal physiology, we talk about functions of the kidneys. When you study about functions of the kidneys, basically in details, then at least we have covered at least, I may say 80% of renal physiology, right? Because everything is going to be coming in under those particular functions. And also, you also have to know about the RAS, long-term regulation of blood pressure, okay? The juxtaglomerular apparatus and its components. So how do the kidneys regulate blood pressure? Through the RAS system, renin, angiotensin, aldosterone system. The kidneys are involved in that, right? The respiratory system hasn't yet been updated, as well as GI. I'll update this afterwards, right? Thank you so much for watching.